And once again, the technique of spotting congruent triangles. We have to use it, we have to apply it. Remember the first thing that I told you. Write every information that has been provided to you in the question as it is in point format. Alright, first write them. Don't invent information by yourself just by looking at some random diagram that you made. There were people in the live class who would just say that is perpendicular, like randomly. It's not given in the problem. I'm not in any kind of way putting them down. It happens. I'm just saying, write it down, stick to what information is provided in the problem. So in the problem, you may pause the video and then solve. We have an equilateral triangle. First thing, equilateral triangle ABC. Second, it is given that DA is equals to DB. Third, point E is also given so that angle DBE equals angle DBC. And fourth, BE equals AB. Lot of information we have been provided and we have to find angle E. This is, by the way, AB. Sorry, this is BC. Okay, now you can do. Yeah. So AD is DB. This is one info. And we have BE equals to AB. This is interesting. We have the equilateral triangle that would make all three sides equal. One other side is equal to these three. So BE is equal to AB means BE is also equal to BC and BE is equal to AC as well. Now what else we have? So from here we concluded that BE is also equals to BC and BE is also equals to AC. Is that clear? Sweet. Now what else do we have? Angle DBE, this angle is equal to this angle. Now you should be already able to spot the triangles. Already. You have this side equal to this side. This side, this side, this side, this side. Angle and this side common. Do you see anything? Now you need to construct a triangle. Let me just make the diagram again. I hope you have seen where the intuition for the construction comes. And you have already spotted the congruent triangles. Okay, this looks like an equilateral. Who cares? Yeah, so we have this point D. Yeah, D will join this. It's in the problem. And E there. And one more. Yeah, this is the problem. We have triangle ABC. This is D. And this is E. We saw this to be equal to this. Why? Triangle ABC is equilateral. And this is equal to this. So this is equal to all three sides. We have also been provided that these two angles are equal. We should have the intuition to think that we need to join these two, and these are the two triangles that are congruent. Triangle DBC and triangle DBE. Are you able to see? It's good if you're able to see. You should be able to see this. How are they? We have DB is equal to DB, that is a common side. BE equals to what? BC, and the angle included, angle EBD equals angle CBD, right? So by SAS congruency criteria, we have this. Now it's time to collect the treasures using CPCT. What treasures do we get? Do we get anything? Angle BED equals angle DCB. If we call this x, this will also be x. We got this, right? We'll also get dc equals to de, dc equals to de, right? Anything else? We'll also get bdc equal to this angle. That won't really help a lot, as you can see. That like, you'll develop that kind of thought process, like something is helpful or not, that intuition with like problem solving a lot of. Okay, that is not a very advanced thing that I just told. That is very easily observable. Okay, this is not useful. We'll skip that. So yeah, this angle is equal to this. Does that solve our problem in any way? It doesn't. We'll have to look for another pair. Do we find anything else? Do we have anything else? Have you used all the information available to you? First information was equilateral, we used that. Second information was what? This being equal to this. BE equals to AD. We have also used that. Third information was this angle is equal to this. We have used that as well. There was one fourth thing, that was AD is equals to DB. Let me just bring the diagram. Here. Perfect. AD is equals to DB. Shit. We haven't used this information. AD and DB. We'll have one more pair of congruent triangles. How? I want you to observe AD and DB are given. What's our goal? To reach some triangle here such that they are congruent. One more vertex we need. Do we? One vertex is already common. We need two more vertex. So these are sides of two different triangles. Don't look at ADB. Don't look at this triangle. Not at all. AD and BD both are sides of the same triangle. Right? Don't look at this one. Why? Because we have to find two triangles, no? So these must be sides of two different triangles. What are those? BD is aligned with this one, BDE. We're just guessing. BDE. And we have AD, we have ADC. Are they congruent? Let's see. So AD and AD are common. BD, no, AD and AD are not common. Okay. We have BE equals to AC. Do we? BE was equal to all three sides of the triangle, so we have BE is equals to AC. Right? Perfect. Okay. So what else do we have? What else do we have? We had this AD equals DB. We have got BE equals AC. So S we have got. We may have one A, as I told earlier, or one more side. What side is left? It's DC and DE. Are they equal? Is DC equals to DE? Yes, it is. DC and DE. How are they equal? We proved this triangle to be congruent to this triangle earlier, and by CPCT these two are equal. I have written this here. Right. So by SSS, what else? We've got BEC, BED, sorry, BDE to be congruent with ADC. Perfect. BDE congruent with ADC. A, D and C. That means by CPCT, angle BED equals to angle ACD equals to this. X. Now what? The triangle is equilateral, so this angle must be 60. So we have 2x equals to 60 and x equals to 30. We are done. First problem, we had to spot one pair of congruent triangles. Second problem, we had to spot two of them. Now, one really amazing approach that I discovered when I was solving this problem back then. So it's really amazing. You would love it. This is the triangle. Here, there's this line, one more, and we have E outside. Right. What I observed was, it looks like this part, this triangle DCE, it was like a paper here, and you turned it, and you just turned it, you folded it, like you make paper planes, right? Paper planes, you fold a paper. It's exactly like you folded it along BD, you just made a crease at BD, and you folded it such that point C reached there at E. Are you able to visualize this? You folded this part you folded, triangle DCB, such that it went there, and it became this ugly looking diagram. If you're able to observe this, what we will do is we'll unfold this paper. Here comes the idea of reflection, taking reflection. How are we going to do it? I'll just erase stuff. I hope you've noted that down. Okay, this is not a live class, you can pause. I keep forgetting. Yeah. So yeah, I'll this is good enough of a diagram. I'll just choose this and move on the other page. Do you have, oh shit, we don't even have a new page. Okay, so now we'll choose it and we'll move it. Yeah, sweet. Perfect. So we'll unfold it. We'll like we'll bring E back to C. What will happen? The triangle will transform to this. We're taking reflection along BD of this triangle BDE. So it will fall. E was here. E was here. It will come to C. ABC. E will coincide with C, and will be done. This is the diagram. That's it. What do you say? This is X. This is X. And 2x equals 60. X equals 30. Now, how do we know? If you're confused about how do we know if BE will perfectly come here and coincide with BC, it can come here as well. It can come inside as well. So we are provided that this angle is equal. So if you take reflection, you know the angle is preserved. Angle of incidence and angle of reflection, whatever. That is preserved. That is equal. So it will fall back to here. So our conclusion is right. So we are right about this. So yeah, you got x equals to 30. I hope you enjoyed the session. And if you want to attend the live classes, because that those are so much better with a lot of discussion going on. There are people trying to prove SAS using SAS. Okay, I'm not putting them down. I'm just kidding.